question for tutorial 7. Okay, so it is intended to produce propylene glycol. Alright, so these are the formula. Okay, whereby we have two kind of rectangle. Okay, just denote it as A plus B is equals to C. Alright, so this occur in a CSTR. Okay, the feed containing 3 mole per liter of propylene. Okay, and 30 mole per liter of water. Okay, so this is the concentration for CA0 and also CB0. Okay, enters the well mixed adiabatic reactors at 303 K. Okay, so this is in adiabatic reactor. Okay, whereby if adiabatic, Q is 0. Okay, and we also can assume the work shaft is 0. Reactor at 303 K at a total volumetric flow rate of 10 liter per min. Okay, so this is given the value of V0 and also this is a T0. Okay, propylene oxide is volatile substance. You cannot exceed an operating temperature of 80 degrees Celsius. Assume that you operate the system at the maximum temperature. Okay, so the maximum temperature is 80 degrees Celsius. Okay, so these are the information given. Okay, we have a delta HRXN, the heat of reactions. Okay, we have the K, alright, at 298, which is K at the T reference. Okay, gas law, the R value, and the activation energy and the heat capacity for each of the compound. The reaction is dependent in propylene oxide concentration and independent of concentration of water concentration. Okay, so water is not included in the react law lah. In this case, it can be treated as a first order and also second order reactions. Analyze and justify the effect of reaction order on the conversion of reaction and volume of reactor. Okay, so the first thing you need to do, what is it? Based on the algorithm. Okay, someone to answer. The first thing you need to topic number 4 tu. Apa yang first thing yang you need to know? I'm kind of worried right now because we're going to have the FA another about 3 weeks. Okay, hopefully by that time you already know all the equation need to be applied lah. Okay, so the first one is you need to know what is the mole balance. Okay, so mole balance is from the okay, which is this case is V is equal to, yes?
Lag, Doktor.
Oh, lag ya? Wait ya, sekejap saya nak refresh internet. Tunggu sekejap Sekejap Okay. Okay, ada lag sekarang. Is it much better?
Okay, Doktor.
Okay, alright. So you have to start with more balance lah. Okay, so the more balance sebenarnya kalau you terus dapatkan dia punya V pun is okay because from the more balance actually we rearrange it to get the V. Okay, so this is CSTR. So CSTR is FA0 X over negative RA. Okay, so and then what you need to do, the second part is of course you have to relate with the red law. So in this case, the question asks you to get, first you have to treat it as the first order, okay, and second one is the second order. Okay, so you have to do one by one. Okay, so for the first order, it should be negative RA is equal to KCA. Okay, and then number 3, is you need to do what is the stoichiometry, okay, in order for you to expand this CA. So negative RA is equal to KCA naught 1 minus X. Okay, so you have to combine these three in order for you to get what is the I just simplify lah, which is W naught X is K1 minus X. Okay, so this would be the equation. Alright, so in this case, you need to get at temperature 80 degrees Celsius. Okay, but the value of the K given is at the T reference. Okay, so you need to get the K at the required temperature, which is 80 degrees Celsius. Okay, so what you need to apply here is using the Arrhenius equation. Okay, which is K is equals to K naught K as exponent E over R, and then we have 1 over T, okay, minus with the 1 over T, okay, 1 over T naught minus 1 over T, okay. So you have to do this one in order for you to get what is better I letak K1 lah, this is K2, this is 1T1, and then this is T2, okay. In order for you to get what is the K2 lah, K2 is around 0.014 min, okay. Make sure you calculate it properly, because if this value you have the wrong value, okay, the rest of the calculation you wouldn't get the correct one, okay. And then of course, once you complete this algorithm or steps, what you need to do is you need to relate with the mass balance, energy balance, okay. So this coming from the mass balance, and another one is for the XEB. Okay, this one is derived from the what do you call it? From the energy balance. Okay, so you need to familiar with the what do you call it, equation. Okay, so you have to know what is the equation used. Okay. Okay, so this would be negative delta H R X N T at the reference, okay, plus with delta Cp T minus T reference. Okay, so here, okay, depend on the information given. Okay, kadang-kadang you boleh terus delta HRX T. Okay, because delta HRX T is equal to this thing. Okay, so here try to get what is the value for this part, and then this part, and this part. Okay, this part you dah given dah, so no problem lah. Okay, so this one you need to have to get the theta CPI, okay, which is CPA plus with the theta B CPB. Okay, so from here the answer would be 215 cal per mole K. Okay, so this would be the answer. Alright, and then what information that you need to get is delta Cp pula. So delta Cp, okay, so this is not reversible, this is irreversible. So you have to consider the Cp for the product. Okay, so this one is CPC minus with the CPB minus with the CPA. Okay, product minus reactant. Okay, this is around negative 7 cal per mole K. Okay, so once you get the value, all this value, you have to put it here. Okay, so T here is the one that the maximum temperature, okay, which is 80 degrees Celsius, convert to the K, and T naught here actually is the T here, okay, starting at the T time equal to 0, which is T naught, the entering temperature is 303. Okay, so this is 303. Okay, K, and 3 reference is 298. Okay, so from here you will get it in terms of XEB. Okay, so sebenarnya ni daripada general equation of mass balance, is just that express the equation in terms of XEB. Okay, so from here you will get what is XEB. So XEB is equals to 0.58. Alright, So you need to get what is the volume. Okay, just put it back into this equation. But X here would be the XEB lah sebab dia dalam keadaan adiabatic. Alright, so this is around 9.8 liter. Okay, 9 okay, see this is the answer. Okay, so for second order pula, okay, so all will remain the same. Okay, this one remain the same, this one is remain the same, except this part. Okay, so this would be negative RA KCA squared. Okay, and the what they call it, the stoichiometry also change to CA naught to 1x squared. Okay, so do the same. Okay, part. Okay, try to get the volume. Okay, in term of this RA. Okay, so and the XCB remain the same. Okay, so you will get the volume is around 782.85 liter. Okay, so you compare lah between these two, which has the less volume. Alright, for the same conversion. Okay, so get it everyone? Okay, so I proceed to the next one. Okay, actually, I'm not sure whether during the guideline, the recorded guideline, I've provided the missing information like T reference, TI, T not, sorry, no, CPA, CPB, CPC, data HRS. And did I provide that data to you? Sebab I rasa I lupa nak attach lah. Okay, so here, okay, actually this question given you the value of CPA. Okay, but I forgot to letak lah 3.2 kg per mole K, and then given CPB is equal to 2.7 kg over mole K, and then we have CPC is equal to 1.5 kg mole K. Okay, and then the delta H reaction, okay, at T ref is given 5 to 520 kg over mole. Okay, so this okay, supposed to be given to you. Okay, after this is at steady state. The feed concentration of A is given 1.2 mol per liter and enters reactor at 8.7 liter per second at 300 K. Okay, so however, the reactor is heated in order to increase the rate and to achieve a conversion of 80 degrees Celsius. 80%. Determine the temperature needed to achieve this conversion. Okay, so from here, you need to know lah what to use. Okay, tengok dulu. I perasan bila I mark your midterm, okay, sebenarnya lagi senang kalau you information in a paragraph like this, you extract dia keluar. Given that apa A is equal to what, C and O. Okay, so that you have to have a clear picture lah. What are the values given and what you need to get. Okay, so it's better for you to extract one by one. Okay, sebab kalau you tak extract, you takut you miss out some of the important value, okay, given in the questions. Okay, so this one is you start with the design of equation lah for CSTR lah. Ikut you lah nak buat ke tak pun terpulang, tapi kena ada the right equation lah at the end of it. Okay, so this is the mass balance, so this will be the zero lah. Okay, so this one, since this is in a CSR, so it should be in RAB. Okay, so you will get lah what they call it at the end is V is equal to FA naught X over negative RA. Okay, so look at that, what kind of information given. So adjustkan dengan apa equation yang ada lah. Okay, so for example, from here you can expand this one, alright, and you will have a V is equal to C A naught V naught X over negative RA. So negative RA here is equal to KCA. Okay, so this is KCA. Okay, ataupun CA naught V naught X. Okay, express the CA, it becomes KCA naught 1 minus X. Okay, so you buatlah nanti ikut algorithm dia. Okay, ni I nak simplifykan sahaja. Alright, so daripada sini sebenarnya sama ada you boleh dapat negative RA dulu, ataupun better you kira negative RA. So daripada sini, sebab apa you boleh kira negative RA? Sebab dia dah bagi what is the K. I tak bagi sini K. K is around apa KI 2.9 10 to the power of 13. Okay, so this one is at temperature reference. Okay, so this is given in the temperature reference. Okay, so from here you can calculate the RA, okay, using this one. Okay, so just manipulate it. Negative RA is equal to, is equal to FA naught X over with the V. Okay, so this one is CA naught V naught X over V. Okay, so V is given here 25. Okay, and it is given the value of the V naught here 8.7. Okay, and CA naught is given here 1.2. Okay, X is 0.8. Okay, so you will have this one is 3.34 times to the power of 10 to the power of negative 4 mole liter second. Okay, so this is the answer. Alright, so and then what you need to get is what is the temperature. So how do you relate the temperature? Actually is using the Arrhenius equation. Okay, so in this case, okay, so we have a K here, alright, and actually the A is given liter mole per second. Okay, so if this 2 is given, you can get the EA, right? If the question is not given EA, so you can get the EA. Okay, so sebenarnya ini adalah previous assignment, okay, masa ODL, which is open what do you call it, open questions. You have to get certain value. Okay, dia tak available in this question. Tapi I bagilah terus untuk ni supaya you dapat a brief idea lah how to get those missing value. Okay, so from here actually, okay, if the question does not provide you EA, you still can get what is EA from the Arrhenius law, which is K is equals to A exponent negative EA over RT. Okay, so the T is used at the T reference, which is 298. Okay, so K is given here. So guna yang ada 2.9 times 10 to the power of 13. And then, so value I sama ni, sekejap ya. Is sebab benda ni I tukar jadi close ended sepatutnya. Okay, so okay, I just lab this is value for A, which is 2.9 10 to the power of 13 liter mole per second. And sorry, dia given EA sebenarnya, dia tak given EA. So given EA J per mole. Okay, so this is given actually. Sorry, I salah tengok. Okay, ni I give lah, tapi sebenarnya dalam tu dia tak ada, you kena cari. Okay, this information sebab this is open ended. Okay, so masukkan balik, sorry, this one. Okay, so kita boleh cari what is K naught. Okay, so K naught is equals to A is given which is 2.9 10 to the power of 13. Okay, exponentkan dia which is 90 kilojoule ni, jangan lupa this one is 90,000 lah. Okay, jangan lupa convertkan dia. And then with R, okay, R guna R yang sesuai untuk this case lah, for mol dengan liter. Okay, and then we have a T temperature which is at 298. Okay, so this answer you will get the K naught. Okay, so K naught is around kenapa orang yang lain? Okay, K naught ni you will get around you kira balik and you will get this answer K naught. Okay, so daripada K naught ni actually you will relate with the Arrhenius equation yang you boleh pecahkan daripada T. Okay, so we have a negative is not 1 minus X. Okay, so this one is equals to, boleh pecahkan, A to the power exponent negative EA, okay, RT, and then CA naught 1 minus X. Okay, so this is negative RA. So negative RA is the one that you already obtained. Okay, so A ni sama ada you nak guna, A ni boleh you direct lah terus 2.9 10 to the power of 13. Alright, EA yang given tadi 90,000, RT. Okay, so sekarang ni kita boleh cari what is T lah. Okay, so T here is the one that temperature needed to achieve this conversion. Okay, so negative RA masuk kembali ke power 13. Okay, exponent 90,000. Okay, over dengan R, okay, which is 8.314. Okay, times with the T yang kita nak determine. Okay, so from here you get what is T. Okay, so T is equals to 288K. Okay, so this is the answer for the T to temperature needed to achieve the conversion of 80%. Okay, so this would be the answer. Alright, so for B, okay, determine the heat transfer kJ over second requirement of the reactor to achieve this conversion. Okay, so from here you need to get what is the Q. Alright, so this is, you need to get what is Q. Okay, so this one is not in adiabatic. Okay, so if it's not mentioned adiabatic, usually dia adalah non-adiabatic. Okay, alright, kalau dia tak mention adiabatic, okay, treat it as non-adiabatic. Okay, so from here you need to start with the energy balance, whereby we have a heat in, okay, minus with the heat out, okay, plus with the heat generate, okay, atau we call generation lah, minus with the consumption, okay, equal to accumulation. Okay, so in this case it is in steady state, so this one is 0. Okay, so this one you have to keluarkan, pecahkan, alright, which means that, okay, we have E Fi naught Cpi T naught minus Tr. Okay, nanti I akan tulis this is what, okay, minus with the Ei, alright, Fi Cpi T minus Tr, okay, plus with the delta Hrx and Tr, okay, Fa naught x, okay, is equals to 0. Alright, so this will represent the energy in the reactor. Energy flow in, energy flow in, energy flow in. Okay, and then this one is the energy flow out. Flow out. And this one represent the energy due to the heat reaction. Due to reaction lah. Okay, so actually this one is coming from the basic equation, which is Q is equal to Ws, okay, plus with the, remember yang mula-mula topik number 7 tu kita belajar E in term of energy, alright, which is in, okay, minus with the F out, E out is equals to 0. Okay, ni equation 11-9. Okay, so daripada situ kita boleh pecahkan sebenarnya this one, in this case WS is 0 tapi Q ada sebab dia ada heat transfer berlaku. Okay, which is this is a non-adiabatic. Okay, so you tak boleh consider sebagai 0. Okay, so this one actually it can be expressed in terms of the heat capacity, this one Cp, alright, and also heat of reaction with the flow. Okay, that's why dia tulis energy flow in, energy flow out. Dia berkaitan dengan flow here. Okay, so this one you have to adjust dengan apa information yang ada. Okay, so dia akan refer to the same general equation, it's just that you bila you derivekan dia, you kena suit dengan whatever information that have in the questions. Okay, so for example, okay, saya guna benda ni sebab I can get what is the FA, what is the FB, what is the FC. Okay, because FA is equals to, okay, remember this is reactant, so 1 minus X. Okay, and FB and FC adalah dalam product. This is the product. Okay, this is product, this is reactant. Okay, so FB is equal to V0 times with the B. Okay, ataupun V0 CA0 X. Okay, V0 ni sebab apa? V0 ni CB ya, B ataupun kau nak senang ingat CB is equals to what do you call it? FB over V0. Okay, basic dari sini je, just rearrange V0 times with the CC. Remember this is what you call it, product. Okay, so pecahkan this one is equals to what do you call it, V0 CA0 X. Okay, sebab CB is equal to CA0 times X and CC is equal to CA0 times X. This is from stoichiometry. Okay, this is from stoichiometry. Alright, kita dah cancelkan yang theta tu lah sebab this is in product. Okay, so daripada situ sebab information of V0 is given, CA0 is given, X is given, so you boleh dapat FB, FC dengan FA. Okay, so from here you kena express, keluarkan dia, expand this equation. Alright, so it ini will become FA0, alright, and then CPA, ni I ni and ini lah species dia, alright, times with the T, okay, I letak si T inlet lah, okay, minus with the TR, okay, T0 adalah T inlet lah I buat, okay, and then untuk flow out, okay, sekarang flow out I tukar jadi not lah supaya you jangan confuse lah, okay, so I tulis kat bawah sini adalah minus with the, pecahkan dia CPA untuk species A, B and C. So FACPA times with the T0. Okay, T outlet. Okay, so I ni sekarang ni I represent I sebagai inlet. Dia sama je kat sini tapi cuma I ubah ni supaya you nampak lah. Okay, sebab I mana letak I, O ni I, nanti lagi confused. So this one, O is actually is outlet. Okay, so don't get confused. Okay, pecahkan lagi. Untuk FB pula, which is FB CPB times with T0 minus Tref, okay, and then minus with the FC CPC times with T0 minus with Tref, okay, so dah habis term ni, pergi pula dekat energy due, alright, due to reaction ni, plus with the ataupun this one, it should be in minus kalau apa sebab dalam value ni adalah negatif, so kita boleh letak negatif lah given, okay, tapi tak pula I letak dulu delta HRX, nak you confuse, okay, TR times with the FA0X, okay, jangan lupa plus dengan Q, okay, so we have a Q here is equal to 0, okay, so this one is we put it as a Q sebab ada heat transfer. Okay, so we have a heat transfer, heat being transferred. Okay, so daripada situ sebenarnya what you need to get is what is Q. Okay, so FA0 dah diberi. Okey, FB cari daripada sini, FC cari dari sini, daripada equation 2 ni masukkan FA, FB, FA0, and then CPA, CPA, CPB, CPC dah given, and delta HRXN pun dah given. Okey. Okay, so sekarang ni what is TI minus TR? Okay, dengan T0 minus TR. Okay, so make sure bila you masukkan temperature kena betul. Nanti you akan dapat the wrong value. Okay, so reference here adalah sebenarnya dia dekat given is at 0. Okay, this question T-ref dia adalah 0. Okay, so kalau dia bagi 298, you letak 298 lah. Kalau dia bagi ikut pada T reference yang dia bagi. Okay, dalam question ni saya tengok adalah T ref is equal to 0 sebenarnya dia letak. Okay, so you letak T ref ni adalah equal to 0. This one is equal to 0. Okay, 0. Alright, 0. Okay, and then what is TI? So TI yang mula-mula tu lah, yang operated tu, which is 300. Okay, so this one 300. Okay, so this is initial, which is 300. TI adalah 300, and T0 actually is referring to yang you dapat daripada sini. Sebab conversion yang kita nak achieve last kali adalah 80%. So yang keluar dia adalah T outlet lah, temperature outlet dia. Okay, which is yang you dapat dia 288K. So masukkan sini, T0 dia adalah 288. Okay, this one is 288. Okay, so jangan salah tau. Kalau you salah dia punya value T, semua akan salah. Okay, so from here you will get Q is equal to 9340. Okay, alright. Okay, kalau nak letak apa-apa nak tanya je ya, jangan malu segan. Okay, now we go to part C. Okay, so part C, if it is suggested to add a heat exchanger. Okay, sekarang ni kita ada heat exchanger and a second reactor in a series with the first CSTR. The coolant fluid enters and exits the reactor at a constant temperature which is less by 100K from the exit temperature for the first reactor. Okay, so kita ada actually a reactor. Okay, tambah slide. Okay. Alright, so sekarang ni dia ada dua reactor, okay, which connect to a heat exchanger. Okay, then connect to another one, which is CSTR. Okay, so from here dia dah given dah what is the value of FA0 from the question, and we have a CA0. Alright, and we have the V0 and also T yang masuk sini. Alright, T inlet lah, 300K. Okay, so here we don't know what is the FA1. Okay, and from the first reactor it is a 0.8 dimension. Okay, and T0 here yang you calculate from A tadi is 288K. Alright, so this is the Q lah yang kita nak tahu dia punya heat exchanger. Alright, and then we don't know what is FA2 here and what is X2. Okay, so the question asks you to get what is the X2. Alright, and T here is 100K. Okay, alright. So from here, remember kalau ada heat exchanger, you kena tengok pada coolant tu, which is we have this diagram dekat dalam lecture note, which is we have a coolant in and coolant out. Okay, so this one is applied to Q is equals to MCP. We have a TA1 minus with TA2. Okay, so TA1 adalah TA yang masuk and TA2 adalah yang keluar. Okay, so kita ada masuk sini and keluar. Alright. Okay, tapi dia punya MC still sama saja untuk in and out. Okay, and also the CP is the same. Okay, that's why dia dah simplify, yang changes adalah in term of the temperature. Okay, so daripada situ you kena kira lah what is the UA TA1 minus TA ni. Okay, which is the this one is equals to okay UA TA minus T. Okay, I simplifikan lah supaya jangan ni, sebab kita consider this is very high flow rate. Okay, so bila high flow rate, the T only. Okay, this is the one that in the in the lecture notes tu dah has been explained lah kenapa this one equation being summarized like this. Okay, so from here UA is given, okay, which is 2.3. Okay, and then we have a TA here. Okay, consider as a T adiabatic is 288 lah, sebab consider dia masuk. Okay, sebab yang keluar dekat T0 lah 288. So yang masuk dia adalah dekat coolant ni adalah 288 lah. Keluar dari reactor, masuk daripada ni sama. Okay, so this one is 288. Alright, minus with the T. Okay, so sekarang ni T is not given. Okay, so you kena buat assumption. Okay, so T dekat sini you can put it as 150. Okay, sebab dia kata the coolant fluid enters and exit the reactor at a constant temperature which is less by 100 K from the exit temperature for the first reactor. So 288 minus 150, you have 38138. Okay, so just put it as 150. Okay, so you will get this one is around 87.4 kilojoule per second. Okay, so here it says that there is a dual CSTR. Okay, so from here they say it is suggested to add a heat exchanger and a second reactor in a series with the first reactor. Alright, the coolant fluid enters and exits the reactor at a constant temperature is less by 100 K from the exit temperature of the first reactor. Both reactors operate at a similar temperature. Calculate the conversion existing in the second reactor. Okay, given the UA is 2.3. Okay, so this one assume that we have two reactors. Okay, so from here kita assume dia nak ada untuk dua heat exchanger here ataupun dua coolant. So 2Q plus with the, instead of tadi 1Q from the previous equation, you put TQ and use the same equation here. Okay, Q you already measured it. Alright, you have the UA from here. Okay, and then plus tadi the FA naught, and then CPA times with the T I minus with T reference, and then minus FA, CPA, and so on. Okay, here what you need to get is what is the X. So this one is plus, so minus with the plus with delta H R X and 0. Kita nak dapat ni adalah X here. Okay, so you arrangekan dia in order to get the X. Okay, so the value is around 0.0204 dekat X. Ni adalah untuk X2. Okay, so this is the value. Okay, so this one same equation used, is just that you put dua here. Okay, since there is a dual reactor involved. Okay, and what you need to get actually is the X here. Okay, put it all the values and get the X here, X2, which represent the X exit at the second reactor, 0.0204. Okay. Proceed to the next one. Okay, so this is okay, so an isothermic elementary reversible isomerization is given A to B. Okay, so this is reversible. In liquid phase is carried out adiabatically. So dia dah bagi tahu this is adiabatically in a CSTR. Okay, so pure A is fed to the reactor at a concentration of 5 mol per liter and feed rate of 500 mol per min. Okay, so dia dah given what is the FA naught and what is CA naught. Okay, as a researcher, you need to analyze the effect of different inlet temperature to the rate of the reactions, okay, which varied from 50 and 100, and another two inlet temperature is 70 to 90. Perform your calculation based on energy balance and thermodynamic equilibrium conversion in a range of 10 to the 130 degrees Celsius, noting that 95% equilibrium conversion was achieved. Okay, so conclude your finding. So this is the information given. Okay, alright. So again, do the same algorithm. Okay, you have to start with the red law. Okay, kalau untuk reversible, so you boleh start terus dengan red law lah. Alright, so red law, okay, you kena derive lah, is equal to K CA minus with the CB, okay, over with the KE. Ni the one that I dah simplify. You kena buat RA net dia lah untuk forward dengan reverse. Okay, and then you, at equilibrium, negative RA is 0. So it, bila you summarize, you can get CAE is equal to CBE, okay, over KE. Okay, ni I dah explain dulu masa lecture. Okay, so you buat for the stoichiometry. Okay, so this is liquid phase. Bila liquid phase, alright, V akan equals to V naught. Okay, this is liquid. Kalau dia gas phase, kita akan buat V is equal to V naught 1 plus epsilon X. Okay, so this is liquid, so kita consider yang ni. Okay, so this one is CA is equal to CA naught 1 minus X. Okay, so stoichiometry akan sama je, tak kisah reversible ataupun irreversible. Yang difference dia adalah red law dia. Okay, and also K dia. K dia adalah K besar. Okay, and then we have a CB is equal to CA naught X. Okay, sebab dia adalah produk. Okay, so you kena rearrangekan dia, alright, masukkan balik dekat sini sebabnya kita nak dapat in term of XE. Remember, I cakap dulu the ultimate goal actually is to get the XE with respect to KE. Okay, so that when you vary KE, you get a variation value of the XE. Okay, sebab kita nak buat a table which have the T here. When you vary the T, you will have a different KE, and when you vary the KE, you will get a different XE. Okay, sebab you nak plot actually is XE, okay, XE and also XEB. Okay, you need to get what they call it, the intersection. Okay, so that's why you have to have a certain several number of point here. Okay, to generate a graph. Okay, so here rearrangekan dia, you akan dapat okay, so just put the temperature here. Okay, it mentioned that the thermal equilibrium conversion in a range 10 to 130. So you start with 10 until 130. Okay, so just vary each of these. You try to get what is KE. So KE, okay, this is given for KF and KR. Okay, so what is the definition of KF dan KR ni? You kena letak value dia lah. Okay, so starting from the exponent, this one is 70.2 T, you kena letak dalam as a KE is equals to KE298. Okay, exponent. Okay, remember kalau K besar, dia bukan dalam bentuk Arrhenius equation biasa, which is ada activation energy. Ini dia ada delta HRXN sebab dia dalam KE, dalam equilibrium constant. Okay, not rate constant yang biasa. Okay, so this one is negative delta HRXN over with the R, okay, times with 1 over T, okay, 1 over 298 lah dekat reference dia. Okay, so KE dekat equilibrium ni dia dah beri, which is 300. Okay, so T ni you kena what do you call it, T ni you kena ikut pada temperature yang you set ni. Okay, then you will able to get what is the KE. Okay, so use this equation to get the KE, okay, by varying the T. Alright, and then once you get the KE, buat yang ni. Okay, so first step, list the T range. Second step, get the KE, and the third step is get the XE. Okay, so you will have this lah. Okay, so this one I bagi nilai XE je. Okay, you try to kira lah starting. Okay, 996. Okay, 0.848, 0.565, 0.259 dengan 0.098. Yang ni I vary ke 10, 30, 50, 70, 90 dengan 110. Okay, try to dapat KE ni. Okay, so kalau sini salah, semua ni akan salah. Okay, so hati-hati bila tekan calculator lah. Okay, now what you need to do is, you need to get what is XB. Remember, XB comes from the energy balance. Okay, so from here, SEB agak senang kalau reversible sebab dia direct sahaja. So we have a theta I CPI T minus T naught. Okay, over with the this one, I pecahkan dulu nanti takut you tak faham. Okay, so in this case, remember kalau the reversible and it involve pure A sahaja. So this one can be cancelled. Okay, this one is for pure A untuk reversible. Okay, so from here, masukkan balik, cari nilai this one, theta I CPI. Alright. And then ni tak ada masalah juga sebab dia pure. So theta I ni akan jadi satu lah, CPI jadi CPA sajalah. So you tak perlu kira the product. Product untuk theta B akan jadi 0. Okay. So daripada situ you will get is equal to 1050 T minus T naught. Okay. This one 75,000. Okay. Delta HRX ni adalah 75,300 and dia dah beri. Okay. So sekarang ni you kena varykan temperature here. Okay. In order to get the XEB. Sekarang ni dia dah mention dekat questions, there are 4 inlet temperature. Okay, whereby we have a 50 degree Celsius. Okay, we have a 100 degree Celsius. Okay, kita ada 70 and berapa dah saya tak ingat lah. Okay, we have 70. Okay, so this one will be the temperature inlet lah. Okay, so daripada sini adalah T dekat T naught dia. Okay, so again guna balik T. Okay, tapi you starting with the XEB. Okay, ni untuk XEB. Okay. Okay, so sekarang ni XEB dia katakan tadi dia ada 4 inlet, you kena test satu. We focus for first inlet, which is start at 50 degree Celsius. Okay, so you punya temperature, you start sini 50 lah. 50, 60, 70, 80, 90 and 100 and so on. Okay, and then convert lah dekat K in order for you to get what is the XEB. Macam mana you dapat XEB? Masuk balik dekat equation ni. Okay, so untuk ni I bagi jawapan dulu supaya you try. Okay, so this one 0, 0.139, okay, 0.279, 0.418 and then 0.558 and 0.697. Okay, so once you get this one, you kena plot lah. Tadi guna balik yang XE tadi, XE tu tak akan berubah. Okay, so guna balik tu, simulate graph dia and also what is XEB. Okay, so you have a XE here and this one is XEB. Okay, try to get what is the adiabatic conversion dengan adiabatic temperature. Okay, lepas tu ulang balik untuk inlet dan seterusnya, which is 100. Okay, so this one, kalau you baca this one, dia kata dia ada tricky sikit, noting that 90% equilibrium conversion was achieved. Okay, means that whatever you get the X from the okay, whatever you get X here. Okay, katakan this one, for the first one, you will get here is X adiabatic adalah around 0.56. Okay, dekat adiabatic equilibrium kita panggil. Okay, yang ni lah dapat sini. Okay, so this one, you can dapat new X, which is this 0.56 kena darab dengan 0.95. Okay, so every graph yang you dapat for 100 degree Celsius, for 70 degree Celsius, for X adiabatic equilibrium, you kena darab dengan 0.95. Okay, so once you darab dengan 0.95, okay, you dapat 0.532. Okay, so daripada sini kita boleh tahu what is the exit temperature. Okay, masuk balik. This is T is equal to T naught plus with the delta HRXN, okay, CPA times with the X. Okay, ni pun dapat energy balance. It's just that you arrange energy electricity outlet is around 361.15K. Okay, so 361.15K. Sebab this one you need to compare in term of the conclude your finding. Sebenarnya dia tak bagi tahu pun, you kena tengok dari segi apa. Okay, so you kena faham lah. Kalau kita nak tengok sama ada performance of each of the inlet, kita akan tengok pada heat of fractions. Sebab kenapa? RA net U is equals to KFCA minus with the KFCB. Sorry, KF dengan KRCB. Okay, sebab kita ada A to B which is KF and this one is KR. Okay, so daripada situ macam nak dapat KF, KR, tengok pada ni, this one. Okay, so T ni adalah dekat temperature outlet. Okay, this is temperature outlet. Okay, this is temperature outlet. Okay, masukkan balik. Okay, and then masukkan nilai CA minus okay. So you will have negative RA. Kalau untuk 50 degree Celsius, you akan dapat around 149 mol per liter minute. Okay, so you kena repeat balik. Buat yang sama untuk XEB, 100, 70 dengan berapa tadi? 50, 100, 70 dengan 90. Kena buat 4 temperature. Okay, so and then dapatkan negative RA, compare. Okay, faham ke? Faham ke?
Ya, faham Doktor.
Okay, so saya bagi nilai akhir untuk RA ya, tapi try dapat gases, RA dia adalah negative RA. Negative RA dia adalah 1.625 okay, mol. Unit dia dah semua mol per minute ya. And then apa lagi, 90 degree Celsius. Okay, RA dia bersamaan dengan 4.094 mol L per min. Okay, so try dapatlah jawapan ni. Okay, soalan ni memang kena 24 hours test. Ni dia ada 2 soalan tapi ni salah satu soalan dia lah. Okay, so remember this one still remain the same, sama je untuk SMSE, yang berubah adalah dekat XEB ni. Okay, sebab ini adalah daripada mass balance. So mass balance akan tetap sama je untuk temperature. It's just that dia akan berubah dekat energy balance sebab temperature inlet dah berbeza. Okay, alright everyone? Okay, so I proceed. Ini I kena cepat sikit lah. Soalan last ni actually adalah previous semester punya. Soalan final actually. Okay, so sebenarnya soalan tu the steps I dah discuss lah dalam kelas, dalam recorded versions tu. Okay, so I bagi jawapan dia last je lah ya. Okay, so this one again you still kena dapat what is the line lah for XE dengan XEB. Okay. Okay, sama sahaja. Okay, it's just that this equation dia adalah equation untuk okay, sebab dia dalam words tau, so you kena translatekan dia. Equation dia adalah A plus B is equal to C plus with the inert. Okay, tapi dia dah bagi tahu dah consider water and acetic inert in the product. Okay, so kita tak ada inert, so kita this one kita jadi zero. So you akan consider A to C sahaja. Okay, so this one apply to question yang sebelum ni, macam yang dapat red law dia, sama sahaja. Okay, yang previously I dah tunjuk. Okay, so daripada situ 70k and this one is 0.45. Okay, so daripada situ kalau you tengok X untuk adiabatic equilibrium dia sangat rendah, which is 0.45. Okay, increasekan dia kita kena guna interstage cooling ataupun heating. Okay, so daripada situ you sebenarnya kena buat graph macam mana nak naikkan dia. So this one of course kita kena ada letak satu, which is this is temperature inlet. Okay, in order for you to get here, zigzagkan dia. Okay, sampai you dah tak boleh touch dah kat sini, inilah dia punya XE dia. XEA dia, okay. So dalam sini you akan dapat X final dia dalam lebih kurang 0.9 0.9 to 0.8. Okay, ikut pada accuracy pada awak punya graph tu. Okay, so kalau in between here, you boleh dapatlah markah. Okay, so you kena determine berapa banyak cooling nak letak kat sini. Alright, so this one yang sini mewakili reactor, sini mewakili heat exchange. This one mewakili reactor, this one mewakili heat exchange. So tengok berapa banyak heat exchange yang boleh dapat dalam situ. Okay, so dalam sini saya dapat dalam around 2 cooling. Okay, 2 heat exchanger. Sorry. So dalam 2 heat exchanger. Okay, so saya punya ni answer lah. Alright, so you kena determine berapa mass. Okay, and then connect to another one. Okay, and then this one. Yeah.
Boleh ulang balik tak dari
yang mana?
Dari yang start case reactor ni, sebab dia lag tadi.
Alright, okay. So sebenarnya bila you buat jawapan mula-mula, okay, you akan dapat this is XE punya line dengan XEB. Okay, jalan cara dia sama juga macam previous question. Okay, then you akan dapat masa you buat calculation nanti, this is 570k. Okay, yang ni penting tahu. Okay, so guna balik step yang macam previous question is just that, okay, you akan dapat, okay, sini XE, okay, this one is XEB, okay, so I akan bagi jawapan terus lah. So XEB, you akan dapat lebih kurang temperature dia dalam 570k, okay, and then X here you akan dapat around 0.5, okay. So from here kalau you tengok XE dia masih rendah lagi. So what we can propose to increase the conversion is by installing a heat exchanger. Okay, sama ada interstage cooling ataupun heating. Okay, so yang bila you dapat dah graph ni, of course kita kena ada start dengan temperature inlet dia berapa. Okay, dalam case ni dia adalah dalam 300k. Okay, so daripada situ you kena start lah. Sini 570, kita nak coolkan dia ke berapa. Okay, so ini adalah target temperature. This one is kalau starting you adalah 570k, kita nak coolkan down dia in order nak tengok berapa banyak dia naik atas sampai dia reach dekat hujung sini. So you akan buat zigzag lah masuk sini. So this is the first reactor. Okay, so kita install apa? Second reactor, second heat exchange, first heat exchanger. Lepas tu this one goes to the second reactor. Okay, and then perlu tak kita coolkan dia lagi sekali sampaikan dia dah reach atas ni dah. Okay, reach this one. Okay, so this one is the new final. Okay, so X final here you of your graph. Okay, so kalau within this range, it is acceptable. Okay, so daripada situ, you tengoklah berapa banyak yang ada zigzag. Okay, katakan from here, okay, what we can see, there are 1, 2, 3. So 3 rectangle. Yang horizontal ni adalah mewakili horizontal, mewakili rectangle. Okay, yang diagonal mewakili apa nama dia? Mewakili heat exchanger, coolant ataupun heater. Okay, depends lah. Tengok pada dia punya pattern macam mana. Tengok pada Genos. Okay, so you propose, so you akan dapat, kalau dalam ikutkan jawapan ni, you akan dapat 2 heat exchanger which connect with the 3 rectangle lah, sebab kita ada 3 yang lurus. Okay, so you lukislah 1 rectangle connect to the first heat exchanger, and then we have a second rectangle connect with the second heat exchanger, and then connect with the third rectangle. Okay, so finally adalah around 0.9 to 0.8. Okay, this one kita achieve tadi dekat X dia adalah 0.45. Okay, so letaklah sini X dia berapa. Okay, tengok pada X yang you capai sini. Okay, so you ada X dekat sini yang keluar dekat ni, and then you have a X yang keluar dekat sini. Okay, so tengok ni adalah tengok pada dia touch ke mana. Sinilah. Alright, so you akan ada 3 lah. Satu yang sini, satu yang sini, satu yang sini. Daripada sini, sini, sini. Okay, so try lah buat. This one is starting from what? Maybe starting with the 350. Okay, yang you nak achieve adalah in between ni 300k. So you nak achieve 300k, this one is 300k. Okay, sebab apa? Sebab this one adalah you fix kat 300k. You nak yang dia keluar dekat heat exchanger ni dekat satu temperature dia, which is 300k. So yang keluar saya ada 300k. This one is 300k. Okay, so yang masuk ni ikutlah pada temperature mana you dapat. Yang ni, yang ni, ni adalah mewakili untuk dekat mana dia keluar lah. Okay, so this one is 300. Katakan this is, I buat 305k, this one akan 57k. 57k ni yang mula-mula you buat ni mewakili first rectangle. Okay, faham ke?
Faham, Doktor?
Okay, alright. Okay, so try buat jawapan ni, dapat tak lebih kurang sama. Okay, so di sini saya dapat dalam 400. Okay, yang ni yang masuk ni tadi adalah 500 lah. Yang sebelum masuk coolant 1 ni 470, yang sebelum masuk coolant 2 saya dapat dalam 400k. Okay, and yang keluar mesti 300k. Yang keluar mesti daripada satu temperature tinggi dia ke rendah. Lepas tu kita naik, dia akan naik pula. And then kita akan rendahkan dia balik ke target temperature setiap heat exchanger tu, outlet dia. Okay, itu sajalah untuk yang ni. Sebab I nak catch up benda lain. Untuk you 9.40, lagi 20 minit je. Okay, so everyone okay ke so far?
Okay, Doktor.
Okay, Doktor.
So kita bincang okay, so saya nak bincang satu question number 5. Okay, sebenarnya ni adalah rezeki kamu. Sebab saya baru perasan bila saya nak buat recorded tu, rupanya saya terbagi you punya revision yang outdated punya. Untuk question A ni sahaja. So you dapatlah free marker untuk semua orang. Okay, untuk question 5, untuk 1A. Sebab I tak perasan, tak ada untuk revision yang I nak bagi kat you, tak ada perkataan ni, the size of each reactor is 600 liter. I forgot to put it. So this one, semua orang assignment 1 punya markah lah nanti. Okay, so I nak buat benda ni sebab ni kita boleh buat revision juga sebenarnya untuk siapa. Okay, so I pergi dekat sini. Ya.
Ya, Doktor.
Lag lagi ke?
Lag lagi, Doktor.
Kenapa lah internet? Sekarang okey ke?
Lag lagi doktor, sikit-sikit.
Oh, naik lagi ke? Kenapa internet saya hari ni? Aduh, teruk pula. Okey, sekarang okey ke tak? Lag lagi ke?
Balik dah
Boleh dah? Okay, alright. Okay, thank you. Okay, so sekarang ni, okay, tadi saya nak cakap yang sebenarnya ada question 5A, saya tertinggal info. Okay, so bila tertinggal info tu tak apalah, saya bagi you full marks tu, that question, 20 marks. Okay, itu sebab saya punya ni lah, saya okay, alright. So question A ni sebenarnya 5A ni, okay, saya bincang ni sebab kita boleh buat revision lah untuk CSR dengan batch. Okay, jap. Okay, so sekarang ni sebenarnya question ni dia given V adalah 600 liter. Okay, untuk batch dan juga balance and so on. Okay, so this question give you the working volume. Okay, remember mula-mula sekali topik yang saya cerita tu dalam reaction ni sebenarnya kita kaitkan volume of the working volume is equals to volume of the reactor. Okay, sebab kalau dalam industri kita tak akan work katakan liquid dalam reactor ni tak boleh dah sama dengan occupy the whole volume reactor, nanti meletup lah. So selalunya dia akan ada range of the volume. So kalau dia mention dalam question dia nak 85%, you kena darab volume of reactor tu times with the 0.85. Kalau dia tak mention ada reactor volume, apa working volume, just assume lah working volume ni akan sama dengan V reactor macam biasa kita buat tu lah soalan. Okay, so dalam sini dia bagi 600 liter, so 600 liter ni times with the 0.85. Okay, so you akan dapat around 510 liter. Okay, so basically you kena remember kalau batch, okay, jangan terconfuse. Batch ni kita ada variable volume, boleh jadi variable volume ataupun kita boleh jadi constant. Okay, so constant volume ni adalah selalunya untuk liquid. Okay, whereby V is equal to V naught. This is volume tau, V besar. Tapi bila variable volume, this one is applied to gas. Okay, gas ni, tengok tak suara lah pula teruknya. So this one is V akan equals to V naught 1 plus epsilon X. Dia ada sini, dia ada ni lah epsilon. Okay, and then we have another one, okay, sama ada dia dalam bentuk flow. Okay, so this flow is in a PFR ataupun CSDR. Okay, and let's say if it's in a liquid, okay, liquid memang volumetric flow rate akan sama dengan volumetric throughout the time akan sama dengan initial. But for gas, dia akan jadi V is equal to V naught 1 plus epsilon X. Okay, so basically benda ni you akan dapat concentration adalah number per volume. Okay, and this one is you akan dapat juga C, tapi you akan dapat dalam FA, F2, V. Okay, so at the end sebenarnya you buat stoichiometry tu you nak dapatkan concentration saja, tapi dalam ni jangan silap. Okay, faham tak yang ni maksud saya? Okay, so constant volume ni adalah dia tak akan berubah. Kalau variable volume ni, okay. And then for akan depends pada YA naught. Okay, that's why this one you akan start dengan PV is equal to nRT. Okay, tapi P ni you kena remember dia adalah P naught and this one is T naught, and you will get katakan this one is N over V. Okay, N over V. Okay, N over V. So this one is P naught RT naught. Okay, NV ni adalah untuk total. Okay, total which is dekat CT naught, the whole mixture kan dia, which is CN naught akan YN naught times with the CT naught. Okay, and theta ni pun remember I dia akan jadi sama ada in term of FA FI naught over dengan FA naught, alright, ataupun dia akan jadi CI naught over CA naught, ataupun dia akan jadi YI naught over YA naught. Okay, so this is Mafulia theta. Okay, kena remember lah ni basic concept. Okay, so dalam benda ni, okay, mention kalau kita start dengan batch, of course kita kena start dengan number of moles, ni lah moles. Okay, kalau dia tak bagi concentration terus, you kena start lah. Okay, sebenarnya dia bagi 1/4. Sebenarnya dalam question ni you kena buat assumption dulu. What is the total number of moles in a mixture? Okay, so you boleh start dengan 100. Okay, katakan you start with 100 moles. Okay, so you can get what is the mole for HMF and also H2O. Okay, for example, we have a moles of HMF. Okay, adalah 1/4. Means that 1/1 plus 4 times with 100. Okay, so you get this is 20 moles. Okay, so lebih dia adalah H2O, which is you can minus lah. So moles of H2O is 100 H2O 100 20, sebab condition is number moles per volume. So you akan dapat what is CA naught and what is CB naught. Sebab number of moles is 20 moles. You boleh divide it with the volume, which is 250 liter, and then this one 80 moles divided by 410 liters. Okay, faham ke? Faham ke everyone? Ada lagging ke?
Boleh doktor.
Okay, ini saya bagi basic konsep dia dulu biar awak macam ada idea lah. Okay, alright. Bila dia cakap dia nak production capacity, okay, which is dia nak sebenarnya mass ni you kena faham tau, sebab benda ni pun you akan relate dengan ni tau, design project nanti bila you final year. Okay, mass flow rate kita selalu kira dalam kg per day. Kita nak tahu berapa banyak product being produced, alright, per day. Okay, so bila you ada benda ni, okay, you kena dapat unit dalam kg over day. Okay, so macam mana kita nak relate dengan kg? Of course, kita nak relate dengan kg, kita kena tengok pada concentration. Usually lah. Okay, sebab you takkan kira directly dapat kg. You akan start dengan concentration. Okay, and day ni, of course, dia berkaitan dengan time. Okay, so time ni dia akan sama ada dia akan refer to T atau tau. Okay, so daripada situ inilah information yang you kena dapatkan dulu. Alright, so katakan tadi kita ada A plus B is equals to C. Okay, C ni lah kita nak produk dia. So what is C? Okay, C is equals to, alright, kalau this is batch lah, N naught V 1 plus X. Okay, so daripada sini kita boleh jadikan this is Cn naught. So Cn naught yang kita dapat tadi, okay, masukkan value dia in order to get what is Cc. Alright, so dalam yang saya dapat tadi around 0.07605 mole per liter. Okay, so this would be the Cc. Okay, sekarang ni kita nak dapatkan T. Okay, kalau untuk batch, okay, you kena start. Remember macam mana kita nak kaitkan T? Of course, kita kena ada differential equation, which is this one. Remember RAV, this is equal to dNA over dt, which is paling senang kalau you ingat. RA is equal to 1 over dNA over dt. Ini daripada topik first. Okay, so daripada situ kaitkan dia macam mana nak kaitkan dengan CA dengan CA0, sebab dalam ni kita boleh dapat information untuk CA and also CA0 untuk dapatkan what is T. Sekarang ni kita nak integrate T ni sebab kita nak dapatkan what is T boleh untuk kita kira mass flow rate. Okay, so daripada situ remember this is batch, so batch V akan tetap sama V0. Alright, so kita boleh naikkan dia DNA. Alright, ni mesti dah explain dalam previous sebelum-sebelumnya lecture. So you akan dapat dCA over dt. Okay, so dCA over dt is equals to RA. Okay, so now we have a dCA over dt is equals to RA. Okay, so what is RA? RA ni lah berdasarkan ikut pada equation yang diberi. Okay, dalam case tu dia dah kata this is second order, which is RA is equal to negative KCA squared. Okay, so daripada situ RA replacekan dia. Okay, sebab RA ni dia boleh banyak red law ni, dia perlu K towards something ikutlah CA ke CB equals to dCA over dt. Okay, so you boleh pegang tiga ni. It's just that you kena kembangkan dia. Kalau you guna dua ni, you boleh dapat in term of T. Okay, so daripada situ, okay, replacekan dia dCA over dt. Of course, you kena replace sebab you nak integratekan dia into CA. So RA ni tak boleh lah, dia kena ada dalam function CA. So it's equal to negative K CA kuasa 2. Alright, so you integratekan dia in order for you to get T is equal to 1 over K. This one is dekat topic 4, CA minus with the CA0. Okay, you will get the T. Okay, so kira K dia, masukkan nilai K, kira nilai CA, kita boleh tahulah sebab CA is equal to CA0 Y minus X. X is target, kalau 0.95, replacekan dia CA0 yang you dapat tadi, you akan dapat what is CA. Okay, so masukkan T you akan dapat around 347.09 minit. Okay, so repeat balik untuk CSTR. Okay, kalau CSTR pula macam mana CSTR, you boleh start dengan, remember kau nak dapatkan tau dia daripada mass balance dia. Okay, ataupun I dah simplifykan dia, you kena start lah dengan FA0 minus with the FA is equals to negative RAV. Okay, and rearrangekan, you akan dapat V is equal to FA0 X over negative RA. Okay, so tau, remember tau sebenarnya kita guna resident times, maksud dia kita keluarkan dia lah, which is this one, you kena keluarkan CAV0. Alright, this one, this is KCA squared. Okay, so V over V0 you akan dapat tau. Okay, so you automatically you tahu tau is equal to V over V0. Okay, is equal to CA0 V0 X over with the KCA squared. Okay, sini senang saja sebab you dah tahu what is a V. Dia dah bagi 510 liter tapi dia tak bagi V0. Okay, so V0 you boleh cari, dapat daripada KCA squared. KCA masukkan nilai K. K masukkan nilai, CA squared kita masukkan, kita dapat nilai R. So 5.337 times 10 to the power of 6. Okay, ni jawapan dia, mol per L, I mean. So masukkan balik dekat equation ni. Okay, okay, I buat elok sikit lah. Macam ada tak next? Buat kat sini lah, senang. Okay, so kita akan dapat tadi V is equal to CA0 V0 X over dengan negative RA. So negative RA ni kita dah calculate. Okay, CA0 dah given. Okay, V dah di given, X dah di given. So kita dapatkan V0. Okay, so V0 this one is 0.07346. Okay, L per min. Okay, so daripada sini you akan dapat tau. Sebab tau is equal to V over V0. Okay, so tau dalam ni adalah 69425.5. Okay, so you akan dapat T berbeza untuk T CSTR. T untuk batch. And then we have a tau untuk CSTR. Okay, so this information we'll use to get a mass flow rate. Okay, sebab mass flow rate dalam kg per day. Okay, so bila kg over day, okay, you will use berapa banyak mol per liter. This one is untuk cc times with the volume. Okay, which is dalam liter. Okay, times with kita nak get rid of mole kan. So macam ni kita nak get rid of mole, of course kita kena darab dengan ataupun bahagi dengan molecular weight. Sebab molecular weight kita dapat gram per mole. Atau terbalikkan jadi mole per gram lah, ikut pada you lah. So tengok dulu, alright. So kalau ni dalam minit, you kena tukar lah. Macam saya dapat dalam minit, so 1 per minute. 30 minit per 1 hour. So untuk satu hari 24 hours per 1 day. Okay, so that's why you boleh matikan ni dapatlah kg per day. So you akan dapat time ni yang akan membezakan dia. Macam information concentration akan sama saja dengan volume untuk CSL dan pH dia. Cuma time dia akan berbeza. So you akan dapat kg per day untuk CSL lain dengan pH lain. Okay, faham ke?
Okay, doktor.
InsyaAllah Doktor.
Okay, so sekarang ni kan sebenarnya dia back to basic tau. You kena ingat je red law. Apa tu red law? Ingat 3 benda Allah ni. Okay, and RA, this one akan fix. It's just that this one yang akan berubah. Okay, dekat sini. Ikutlah pada second order ke, first order ke. Pada daripada sini lah sebenarnya you boleh integrate in term of T dan CA. Okay, ni dalam topik 7. Okay. Perlu tahulah benda tu, okay, and then you kena tahu macam mana nak rearrangekan certain information. Okay, contohnya kalau you guna sebelum ni you akan dapat CA0 minus CA over CA. Okay, ni pun sebenarnya sorry, RA, this one adalah sebenarnya dalam tu. Daripada volume ni lah you rearrangekan information yang ada. Okay, so basically kalau nak kira tahu memang akan V over V naught lah. Okay, this one is applicable for C, SDR and batch. And PFR. Kalau batch adalah guna macam I tunjuk ni. Okay, so kalau sini first order, so you integrate in term of first order lah. So this one akan jadi CA lah, integratekan dia. So itu dia berubah kat situ sahaja sebenarnya. At the end dia akan back to the equation yang asal. Okay, faham ke? Okay, so far nak tanya apa-apa tak? Equation mana you tak faham so that I boleh brief sikit-sikit lah buat masa ni. You ada kelas ya pukul 10?
Kami ada kelas lepas
Sorry,
ni.
kelas saya memang
Kami
ada kelas ya?
Orang ada test pas ni.
Oh ya ke? Okay. Saya rasa itu sahaja. Okay. Anything you try to PM to PI kalau ada apa-apa yang you tak faham ya? Alright.